Okay, so this is 7.4. This is going to be a little bit of a shorter lesson, but this is the substitution method. Okay, substitution method of what? Well, of solving systems of linear equations. Okay, algebraically, because we talked about graphically. So this one is now using algebra. Okay, algebraically. So graphing is easy. We graph the two lines, find the intersection point, right? The x on that intersection point is the x value, the solution. The y on that intersection point is the y solution. Now listen very carefully. This is a good example to start off with. If you are given, everybody listening? If you are given these two equations only, and I asked you to solve, okay, that is to find out an x that exists for both and a y that exists for both, you would say to me, hopefully you would say, well, Mr. Maxwell, I see that x equals -4. So there's really, this is kind of a no-brainer here. I know what the x value is. The x value is -4 because it's given, right? Now, if I asked you to solve for find the y value for this system, you would say to me, hopefully you would say, well, I know how to do that. I'm going to substitute the x equals -4 into this equation that has both variables, and I'm going to find out what the partner y value is. That's what you'd say to me. It's basically saying, I'm saying, what is y when x equals -4? So you would go like this, no problem, man. I go x equals -4, so I'm going to throw that in there. I don't know what y is, but I'm going to find out. So this is what you would do. This is exactly what you would do. Okay, we add 12 to both sides, and you go y equals, oh, it's going to be some kind of fraction here, I guess, right? 18/5. Does that look right? It's not a very friendly answer, but it looks like the answer. Is that correct? Okay. So throw in -4 in for x and solve for y. So look at what we've just done. We've just done a substitution method of solving a system, that is two equations, algebraically by not graphing. That's what we've done. That's what you just did. So this is not a big scary thing. It's basically thinking, okay, how can I mix the two equations together? How can I substitute something from one equation into the other? Because remember, the solution still happens when the first equation, right, is the same as the second equation as far as the x and y goes. So the x part has to be identical in both. The y part is the same in both. Okay, so let's carry that on to this example now. So this example right here isn't quite as straightforward, but look at it has y already isolated. So here x was isolated, right? X is -4. Well, y is not a number, y is an expression. But guess what? We do everything the exact same way. So let me just rewrite this a little bit bigger over here. This is what we have, and you're going to see how easy this is. Okay? If y has to be the same for both equations to find a solution, look at what I can do. Y is equal to -x plus 3. Well, that's true for this equation. I know that it has to be true for this equation too. So guess what? Whatever y equals can be substituted into the other equation where you see y. You see, y equals blah for one equation, so y has to equal blah for the second equation too. We just substitute. So it's a way of mixing the two lines together. It's a way of getting them together. So this is what you do. You say 2x plus y equals 5. Well, I know that y equals this expression, so I'm going to go 2x plus -x plus 3 equals 5. So you're going to create one equation with only one missing variable. That's what we did over here. It's exactly what we did over here. We created one equation with only one missing variable. So guess what? I can solve for x now. So I go 2x let's get rid of these brackets. Let's just simplify. This is actually minus x and a plus positive 3. So plus 3. Okay? That's just a little easier to think about. So 2x minus x is 1x, or just x. What's x? X is 2. Okay? So for this one, I have found x equals 2. What else do I have to find to solve this system? I also have to find what? Y. I know what the x value is for both equations. Now I have to find the y value for both equations. And how you do that is you simply go back to the beginning and you pick one of these. It doesn't matter which one, because the y value is going to be the same for both. So you pick whichever one you want to work with, and then you solve for y. And look at, y is already by itself, so I'm going to use this one. I'm going to solve for y by putting x equals 2 in for x. You see that? Now I can solve for the partner y value here for x, which is negative 2 plus 3 is 1. So my solution is x equals 2, y equals 1.
That was easy.
Wasn't it? Oh yeah. Okay, so some of you are like, totally makes sense. Got it. And I know some of you are like, okay, I haven't copied this down yet. What does that first equation say? I can't read it. Okay. I'm not looking at anyone. Okay, but let's do another example. Okay, let's do another example of substitution. Okay, so 3x plus 4y equals negative 4. And x plus 2y equals 2. Okay. So here's an example where I'm going to use substitution. Okay. Now remember, with substitution, you want to isolate one of the variables in one of the equations. So let's just jot that down for a little sort of step 1. Okay. Step 1. Isolate one of the variables in one of the equations first. Okay, so let's just bring that over here. So isolate one of the variables in one of the equations. First thing you do, I look at both these equations. Which variable, x or y in the first or x or y in the second, would be the easiest for me to isolate to get it all by itself? Which variable in which equation? What do you think? Thank you. X in the second. Look at this. It's already by itself. It's already got a 1 in front of it. Let's just isolate this bad boy right here and then go with that. So this is x equals, what, 2 minus 2y? Doesn't matter what order you put them in. There you go. See, this equation has become this. Everyone see that? So that's the first step. You have to isolate one of the variables in one of the equations first. Pick the easiest one in either equation. Now, this looks very, very similar to the example we just did, right? You see how I have x equals this right here? So guess what? Step 2, substitute the expression for the isolated variable into the other equation. So let's just think this through here. Substitute the expression for the isolated variable. Well, here's the isolated variable I just did. Here's the expression for it. That's what it actually is equal to. We want to substitute that into the other equation. So guess what? This is what I do. This is what I literally do. Circle it or square it, and I draw an arrow. Okay, this is x, so this actually goes right here. It goes right there into the other equation. So let's do that. Let's substitute it. What do we get? 3 times what? Well, it's not x anymore. It's this now. 2 minus 2y. See that? And then you copy everything else. So you see, this is how we're mixing the two equations. And mixing the two equations makes sense because the solution is where the two equations are kind of mixed at that very point, right? So we have to combine them. Okay? So we substitute the expression. Okay? Step 3. Solve for single variable left in new equation. So here's our new equation right here. And there's only one variable in there, right? So I'm going to solve for now the y. So we got to get rid of these brackets by multiplying 6 minus 6y plus 4y equals negative 4. Gather all like terms and then isolate for that. So negative 6 plus 4 is going to be, that's going to be negative 2y. Let's subtract 6 from both sides. Okay, I don't know if I'm going too fast for you here or not, but hopefully you should be fairly adept at doing this now. Y is then going to equal positive 5. Is everyone get that? Okay. So we've got y equals 5. We've solved for the single variable that was left. In this case, it was the y. Step 4. Substitute value for this variable, into either original equation to solve for other variable. In this case, of course, it's going to be the x. Okay? You guys writing all these steps now? When you don't write them down, that's when you're going to be like, oh, what do I do next? Mr. Maxwell, what do I do next? I'm going to say, well, just look at your steps. And you're going to tell me, I didn't write them down because I was just chilling. So you can chill and write the steps down, okay? I mean, they're not mutually exclusive events. Okay, so back to task here. Okay, so what's the original equation? All right, so I had 3x plus 4y equals negative 4. 3x plus 4y equals negative 4. That was one of my original equations. So let's substitute the y equals 5 in there. See how this is all about substituting? Okay, this is all about substituting. So now I have 3x plus 4 times 5 equals negative 4. And so when I solve this, this is 3x plus 20 equals negative 4. 3x equals negative 4 minus 20 is negative 24 divided by 3, negative 8. Okay, so now we've solved for the other variable. Whoa. We've solved for the other variable. Step 5 then is going to be check to see the solutions for x and y satisfy both equations. So the last part is just kind of a little check. So my original equations, I'm going to substitute the variables in real quick here. So when you plug your x and y variables into each of the original equations, you should get both sides being equal. And if that's the case, like it is here, then you know that your solutions are negative 8 and 5. That's the answer. That's the solution. That's where those two lines would intersect on a graph.